This Cybertruck is unlike anything you've ever seen. A 3D printed, one-of-a-kind electric behemoth that almost broke me, literally. I guess that's what happens when you use real glass and a real stainless steel exoskeleton just like the actual Cybertruck. I even managed to get Gwyneth Paltrow to teach me how to program its microcontroller, but more on that later. Forget cool, this thing is weird, impractical, and cost me a small fortune to construct. But it also pushed me further than I ever thought possible and challenged just about everything I thought I knew about engineering. Buckle up, because today we're diving into a deep build. Elon, eat your heart out because we're building a Cybertruck.
And quick shout out to NordVPN for sponsoring this video.
Now, if you haven't picked up on it yet, this isn't exactly something you can buy off the shelf. Even Amazon, with its zillions of products, doesn't have one of these. And I'm going to explain why that matters. If you think this is just a toy car, you're actually missing the bigger picture. This isn't about a miniature Tesla, it's about a tech revolution happening right under our noses. See, 2 weeks ago, I barely knew the difference between a PCB and a pizza. I couldn't solder a wire to save my life. And now look at me, I built and programmed this tiny Cybertruck. And it's all thanks to this incredible moment in time where a bunch of different technologies have finally come together in a perfect storm of maker awesomeness. We've got the rise of DIY manufacturing hubs like printables, where anyone can design and share open source schematics. It's like a natural selection for cool new products. You don't even need a 3D printer. I don't have one, and yet here we are. You can just order these parts from commercial printing services and bam, they show up at your doorstep. Then there are all the amazing low-cost microcontrollers out there like Raspberry Pi, Arduino, ESP32, and if you can't find exactly what you need, you can design your own PCB and have it manufactured with just a few clicks. The tooling in the space has also received an upgrade with frameworks like PlatformIO, CircuitPython, Flux.ai, EasyEDA, and Fusion 360. Seasoned engineers are already jumping on this bandwagon, crowdfunding their wildest ideas on platforms like Crowd Supply. I've even seen makers on Etsy selling custom-designed LoRa radios that look like they belong in a museum. And I've even had the chance to collaborate with some seriously innovative companies from China, like Rayax, who are pushing the boundaries of what's possible with tiny radios. But the real magic behind all of this is not the 3D printers, it's not the microcontrollers, it's not even the incredible communities of makers sharing their ideas online. No, the real game changer is something else entirely. Something so powerful, it's literally making the impossible possible. So what's the secret weapon? Patience, Padawan, we'll get there. Now, as an engineer with over a decade of experience, I've been involved in some big projects, but this is different, and by the end, you'll have the blueprint to build it on your own if you're crazy enough. However, building this sort of thing is not for the faint of heart. From inhaling lead solder fumes to sniffing SLA resin dust shavings, I wouldn't be surprised if I grew an extra appendage at some point in the near future. So warning, if you're expecting a simple step-by-step tutorial, this isn't your father's truck. Now, you've probably seen the Cybertruck all over the news lately. The New York Times was just calling it a culture war on wheels. And here in Brickell, I'm already seeing them pop up everywhere. Some say it looks like a hotel ice machine, and honestly, they're not wrong. But personally, I'm a fan. I love that clean, unapologetic look. It's bold, it's futuristic. Some might even say it's monolithic. And it's not as out there as some people think. I mean, look around. Modern design is all about sharp angles, glass, and that minimalist vibe. Even boats out here are trending towards hard-edged geometric looks. The Cybertruck is just taking it to the next level.
So like this boat right here is a good example of what I'm talking about, with its straight edges and sort of polygon type look. Looks a lot more like a Cybertruck than a Ford F-150.
So when I saw this project on Instructables, I knew I had to give it a whirl. But of course, I wanted to up the ante and make it even better by adding a few upgrades, including a true stainless steel 3D printed exoskeleton. So I methodically began acquiring all the pieces to bring this idea to life.
First we have super glue, and we have two different kinds. This first one here has a harder finish, while this other one is a little bit more flexible. Next we have Captain tape, because every maker needs some heat resistant tape in their arsenal. Then we have M3 screws, tiny but mighty. These guys are gonna keep everything secure. Next we need some wires. I'm gonna use some GPIO jumper cables. Then we have the 3.7 volt lithium rechargeable battery. This is what's going to give our Cybertruck its juice. Then we have a simple on-off slide switch with a satisfying click. Next is a 1.51 inch transparent OLED display. This is where the magic happens. We'll use this to show some cool graphics and sensor information. Then we have the DHT11 temperature and humidity sensor, because who doesn't want to know if their Cybertruck is feeling a little hot under the hood? Finally, we have the brain of the operation. This is the Seed Studio JAO ESP32C3 microcontroller. It's a tiny but powerful computer that will control everything. And these are called SMD or surface mount resistors. They're pretty tiny, but they help regulate the flow of electricity and keep everything running smoothly. All right, before we dive into the 3D printed madness, let's make sure we've got our trusty sidekicks ready for action. This is a Gerber multi-tool, proudly built in the USA. It used to be military issued, and this has helped me out in numerous dicey situations. This is the Oriya Precision Screwdriver Kit. It has pretty much every head you'll ever need, and I use mine almost on the daily. Next, we're going to want a basic soldering iron kit. This is our weapon of choice for fusing metal and making electrical connections. Don't worry, I'll show you how to use it like a pro. Finally, we need some wire cutters for snipping wires to the perfect length. Remember, measure twice, cut once. Now, this is just the starting point. You might need a few other tools depending on your specific build, but this should get you pretty far. And remember, you can find links to all this stuff in the description below, but here's where things get really interesting. 3D printed custom parts. Now, I've used JLC PCB before. They're my go-to for fast, reliable 3D printing, and they've got a crazy selection of materials, lightning fast shipping, and they even work with you if your design might have some issues. Now, I do want to show you some other things that I have printed. So there's a website called printables.com where folks can share their open source schematics for 3D printed objects. And it's really cool because people fork other people's projects and then they remix them and they edit them, they make them better in some cases. So it's kind of like this natural selection for 3D printed objects, which is quite cool. And so a couple projects that I have printed off here. This is my buddy over at MusiWorks. He has a couple different projects, and this one he decided to open source the schematics. And you can see this is for a Mesh-tastic radio. So I actually sent this to JLC, and I did a nylon backstop. So this guy here I did with nylon, and then for the front face I did the SLA Imagine Black resin. And you can see right here, this was the result of that, and I was very pleased. I really like the black resin finish. It's super durable, and it just looks really high quality. A couple other prints I did, this Raspberry Pi Pico case, I took the same approach. For the backstop, I did the nylon. You can see it's a little bit more grainy and kind of like a matte finish. And then for the front face, I did again the SLA resin black, and the level of detail with these is quite impressive. Like this case here is a snap fit. There's no screws or anything like that, but they're just able to get to that level of precision where it just pretty much works perfectly. And I kind of like mixing, matching different materials as well. It just makes for a really compelling final product. And then finally, I 3D printed a Raspberry Pi 5 case, and I did all nylon for this one, and I think it came out pretty well. It still kind of has the hallmarks of 3D printing, but I'm pretty satisfied with the finished product. This is also a snap fit case. Okay, so I want to run through the process of ordering 3D printed parts from a commercial grade supplier, such as JLC PCB, which is based out of, I believe, Shenzhen. But their shipping times are quite fast, their prices are very reasonable, and the quality is quite good. So first thing you need to do is get the schematic files. There's a couple different file formats, but the most popular you're going to find are the STL files. I was working off of this Instructables blog here, and the author supplies the parts. They're open source. You can remix them, you can scale them up or down in any way you want because you have the base files, but I'm not going to modify them. So I'm just going to go ahead and download these parts. So I'll just add this to my downloads file, and I'll do download. All right, and then once I have the STL files, I'm just gonna go over to JLC PCB and upload those files. And so this shows what everything's gonna look like when it is fully rendered. And so we can just take a peek at it, get a sense for how the parts align with each other and where all the ports are and that sort of thing. Okay, and then let's go over to JLC PCB. So JLC does PCB printing but they also do 3D printing. So we want to come over to that domain. It should say jlc3dp.com. And then the first thing you do is upload your files. So I'm going to go ahead and select everything here, open the files, and it's going to do a quick pre-process of the files to make sure everything is copacetic. So if the parts are too thin, then they aren't able to guarantee the structural integrity of that part, and it will throw an error here. In those cases, you can either beef it up by scaling it in the direction that's needed. It gives you the dimensions so you know the minimums. You can either beef it up, or you can go to another 3D printing company that can support that smaller part. But I gotta say, JLC is really good. When I've done orders in the past, I've actually had them reach out to me and essentially say, hey, we think this part right here is a little too thin, is gonna have issues. And what they'll usually ask is, are you willing to accept that? That's basically what they ask. And I always say, just go for it. And more often than not, the part actually works properly. It's just, they can't guarantee that. So they'll work with you there. So I wouldn't be too worried about that. But if you need to, then you can go to another supplier. But I try to do everything I can with JLC. So like, for instance, this part's not going to work. And these are just like thin panels, like very, very thin panels. This part, I don't think actually looks like that was okay. The panels it doesn't like, but the body's like fine, see? So the next step is to select the material. I have found that, and they have a number of different kind of permutations of different material, but the nylon is a little bit more of a matte material. It has a grade to it, and it looks a little bit more, frankly, like it's 3D printed. The SLA resin, on the other hand, really looks like that cast mold ABS plastic, something you would really buy off the shelf at a store for like a toy or something like that. I'm a big fan of the SLA resin. The finish is usually smooth, and you can get different colors. But as I mentioned, I wanted to try the CNC machining, the metal 3D printed. All you have to do is select SLM metal. The material they have is the stainless steel. This is more specifications around it. And obviously that doesn't come colored. And the price isn't that bad, surprisingly, on these. So I was quite pleased with that. So here's the tire. We want this to be black. We also don't want it to be too smooth. It should kind of look like rubber. So I'm going to do nylon. We're going to do black. For the undercarriage, I want to do the resin. I want this to be smooth, but I also want that black finish again. You could do no finish or have a finish. That looks pretty good. So let's save these to cart. So this piece we would want to be white. So we could do SLA resin, and we could do natural white, or if we did another material, let's see if we can get a different color. So you can get this kind of funky color. Yeah, we're gonna need to do SLA resin natural white here. So every material has different types of colors that it can support. And if you need to know more about the different materials, you can just hover on these here, and it kind of gives you the different properties around the material. There's different finishes, different colors, different levels of durability, heat proofing, etc. And for the description, I usually just put electronic toy or office appliance. Let's see here, DIY entertainment, toy part. Okay, so now we can go to view our cart. Keep in mind that JLC should have some coupons available for you. If I have any, I'll put them in the description below. And you can see the pricing is quite reasonable. I mean, $2 for this, $1 for this. Sure, this is $15, but you gotta realize this is a chunk of stainless steel. So I'm pretty happy with this. And then you just go ahead and check out. Okay, so you actually don't pay for anything until the order is processed and approved. So once you submit your order, they are going to review it. They usually get back to you within 24 hours. Keep in mind they're in China. They will let you know if they have any questions. They will tell you to make any edits as needed. And then they will notify you when the order is good to go, at which point you can pay for it, select your shipping, and complete your order. And then they will get started on printing your order. Okay, but what about for those parts that were too thin for JLC to manufacture? So there's another supplier that I use called CraftCloud. And the way this works is you upload your molds, you select your requirements, your material, color, etc. And then what they'll do is they go ahead and look through their directory of suppliers. And most of those suppliers are stateside. So it's gonna be a little bit more expensive, but it usually ships faster and the quality is pretty good. And then they start giving you quotes. And then you pick one of those suppliers and then you can proceed with the order. So for instance, we can go to upload and I'm gonna grab those parts that were too thin. So we have the light, and then we have the rooftop panel. Let's see here. I think that was this guy right here. Let's go ahead and select open. We select millimeters. So it does still give us that warning. Your model seems to be unnaturally small. Please make sure to check the dimensions of your model, but we should be able to proceed. So let's go ahead and go to materials and pricing. So you do it by part. So for instance, if we want to select the material for the light part, we just keep that toggled. Now we know we want the light to be, this is the headlight, right? We can see basic prices for different materials here. Let's go ahead and just select this nylon here and see if we can't get a white. Let's see here. Yeah, we want painted white should work. Okay, and then it gives you some pricing estimates. So it's a little bit steep. We could probably shop around and get something cheaper, but that's the process, right? And then for the panels here, let's try nylon PA12. Again, there's like different finishes and things. You can do raw, dyed black, reasonable price, add to cart. And then you go ahead and purchase them, and they'll send them out to the different suppliers. And you can see these are the actual companies that are going to fulfill your order. Muse 3D, Jaws Tech. And if we want to just take a quick look here. All right, so this is Jaws Tech. That's right. Yeah, so Jaws Tech is over here stateside, and they'll be shipping out to Miami here. And then the other supplier is Muse 3D. And these guys are in, okay, apparently these guys are actually overseas. So I think they deal with all types of distributors, abroad and domestic. And I've had a lot of, I've had success with these guys. I had them print out a bunch of different pieces for me, and I've been pretty satisfied. It's just a little bit more expensive than a more like a Shenzhen-based manufacturer. Finally, the moment of truth. My products have arrived all the way from China, and it's looking good so far. So you can see I ordered some of the body exoskeletons using various types of plastics such as nylon, and you can see these parts are pretty good quality.
And in order to get our Chow to connect to the internet, we need to flash our script, which provides the device with our local Wi-Fi network name and password. Now, I can already hear the comment section now.
But Tim, are you seriously about to connect a device manufactured who knows where directly to your home network?
Well, that's actually a valid concern, and to be honest, these kinds of security exploits are a much bigger deal now than they used to be, which is why I've recently started using NordVPN to add an extra layer of security to my network. Look, I know you're no stranger to the VPN landscape, end-to-end encryption, IP obfuscation, the whole 9 yards, but NordVPN definitely takes things to the next level. Their threat protection feature is like a next-gen firewall, proactively neutralizing ads, trackers, and even malware at the DNS level. That means when you're browsing, all those hidden third-party requests trying to siphon your data, blocked. Dead in the water. Forget those flimsy browser extensions. NordVPN blankets your entire network with military-grade protection, acting as a DNS sinkhole, swallowing up those data-hungry advertisers and shadowy data brokers before they can even get a sniff of your online habits. We're talking serious defense against shadow profiling and surveillance capitalism. And for the digital nomads out there, the NordVPN mobile app ensures your data stays locked down, whether you're sipping a latte at your local coffee shop or navigating the complexities of public Wi-Fi in a foreign land. NordVPN is your online sanctuary at your fingertips. Ready to protect your online experience? Don't miss out. Head over to nordvpn.com/dataslayer for an exclusive offer. Right now, you can unlock 4 extra months on a 2-year plan, and it's completely risk-free with Nord's 30-day money-back guarantee. Explore the future of secure browsing and click the link now. And big thanks to NordVPN for supporting tech education and keeping us all a little bit safer online. Now, let's get back to building.
Okay, the next step is we need to get the software onto our Chow right here. This thing has a USB-C port. We can use that to load the software. We're gonna need a cable that can support data in addition to power. So I'm gonna connect this guy right here, and I'm going to connect it right to my Mac here. And we're gonna use PlatformIO. Particularly as a code editor, I'm gonna use Cursor. Cursor is just a fork of VS Code that integrates LLMs and GPT and all that. If you don't have PlatformIO on your VS Code, then just go over to extensions and you can look for PlatformIO. You're going to go ahead and install this guy. Once you install this guy, it's going to create some new options for you down here, particularly this home option. The home option shows you all your projects, shows you any devices you have connected, lets you explore libraries, boards, inspect, etc. But we're going to take a look at devices. These are other connected devices over like Bluetooth and things like that. This is the one we care about. USB-C modem. In this case, it's 2101. That will change, so we want to keep an eye on that. It changes based on like where you plug it in and what have you. I'm going to come back over to my project here and close out of this. So this is the directory. The main code is this guy here, but your config file here, which tells PlatformIO like what board are you using, what's the baud rate, what serial port, and a couple other configuration things. Those are defined here. That's going to make your life a whole lot easier. This is all on GitHub. You can just pull it if you need. But the first thing, we just want to make sure that cursor can talk to our Arduino board. So we're going to open up a serial terminal. So we're going to go to serial monitor here and click that. And it looks like we're good. It says terminal on. If it's not working, then you might need to reassign the terminal. You just click down here. Oops, click down here, select the USB terminal, and you should be good. So one little thing to just verify, like there's no messages coming through here, but it seems like we're connected. I'm gonna restart the chow using the onboard reboot toggle here. So you have a boot toggle and you have a restart toggle. Boot is for something else we will talk about in a sec, but restart just turns on the device. So if I click restart here, since we are connected on the serial terminal, I would expect that to log some information. So first you can see it disconnected, then you can see it reconnected, then you can see it started scanning for networks and things like that. That's just the out-of-the-box software that comes on the chow. We're going to overwrite that. But the point is the baud rate is set up correctly. Otherwise, this would look like gibberish. And we can, in fact, see those debug messages logged to the console. So that means we have a good, healthy connection here. So, okay, so that's a good place to start. Essentially, we just want to flash this project here to the chow. Real quick, I just want to show you like what this is doing. So you have dependencies, libraries, configuration files, etc. But most of the heavy lifting is in this main.c++ file. And all it's doing is loading dependencies around Wi-Fi, the display, the humidity sensor, the time clock, and it just has a couple functions here. One to calculate battery percentage, a setup function, a loop function. The one thing that we are going to want to edit on this guy is the Wi-Fi credentials. So this, when the chow starts, it's gonna attempt to connect to your Wi-Fi router. Now it doesn't have as good an antenna as like your laptop or your phone, so it might need to be closer to your router, but it should connect. And you are going to want to supply your credentials right here. So the name of the network, the password. This project also has a bunch of dependencies, these libraries here. So when you fork it, you might also want to open up a terminal in the project and run this command here, PIO update. That'll just clean everything up and make sure your dependencies are all in line. These guys need to be active in the project for this to all work. But once you feel good about the code, then you're going to want to build it. With microcontrollers, you're always compiling the code to binary and then flashing the binary to the hardware. So with PlatformIO, to do that, all you do is build. And you're just going to want to make sure you don't see any problematic errors in this process here. Okay, so that looks healthy. So it just created the binary based on all of the files you have. Now to actually flash it to the device, you're going to want to select upload. Now, this is where the devices get a little fickle. Basically, this device has two states. One is like kind of like a maintenance mode where it's just operating and it's running the code. But then another is like an upload or boot mode. You're supposed to have it in the boot mode in order to flash new code to the device, but I've found that sometimes it'll just work. But if we need to put this in boot mode, we can. So let's just try it first as is, and then we will see where we land. So I'm just gonna do upload. So this means it's working. If it says writing, that means it's successfully working. And what it's gonna do is it's gonna flash it, and then it's gonna restart. And then it should be running the new code. We should be able to verify that because this has some print lines in it, like connecting to Wi-Fi, connected to Wi-Fi. So technically, if we open a serial monitor here, and keep in mind, you can only have one serial monitor at a time. Otherwise, the device will be busy. But so we know we flashed our code because it restarted, and now it's logging this. I didn't give it valid credentials. I gave it this faux passkeys, but so now it's trying to connect, and you can see like every 1 second it's logging this message here. So that worked. Now, if you tried building and then uploading, but it wasn't able to upload, that probably means your device wasn't in boot mode. So there's two ways to get it into boot mode. One is you can disconnect it, you can hold down the boot button, and then you can reconnect it and then lift the boot button. That should put it into boot mode. But a second is you can hold down the boot button, and then you can click restart, and then you can lift the boot button, and that should actually put it into boot mode. And we can actually confirm that because if we come over here, this was our serial monitor that was connected to the device. If it had loaded in that sort of steady state maintenance mode, it would have executed the script and it would have started logging connecting to Wi-Fi. But you can see it says we're connected, but it's not logging as connecting to Wi-Fi. That's because it is in boot mode. It's ready to receive an upload. And so we can go and boot it, we can upload it again if we want. So let's go ahead and do that. And it should say writing, there it goes, writing. And then again, it's gonna restart, and then it's gonna run that same code. All right, yeah, sometimes it just gets finicky, but I disconnected, I reconnected, and now we can see the code running as expected. So it's logging these messages to the serial terminal, so we should be good to go. We can get started with the soldering, and it'll just run that code anytime it gets power. Okay, and so the final secret weapon that I was alluding to that helped me out with this build was access to powerful LLMs like ChatGPT and Gemini. And I was able to ask a number of salient questions, such as how to modify my C++ code to print out additional diagnostic information. I am not fluent in C++, unfortunately. I understand the gist, but if I want to get everything perfectly syntactically sound, I can just grab the code and I can pose a query like this.
Here's the rewritten script that logs the battery voltage and percent charge. CPP key, copy code float rate battery voltage, int analog value.
I could also ask it a bit more esoteric questions like how best to go about validating that the chow is receiving the proper current from the 3.7 volt lithium rechargeable battery.
To verify that your Seed Studio chow board is receiving the proper current from a connected 3.7 volts battery using a multimeter, follow these steps. 1. Set up the multimeter. Turn on your multimeter. Set it to the current measurement mode A, typically denoted with an A or mA symbol. Choose the appropriate current range. If you're expecting small currents, start with the milliampere mA setting. 2. Break the circuit. To measure current, you need to break the circuit so that the multimeter can be placed in series with the component. Disconnect the wire, connecting the battery.
So full disclosure, this was my first soldering project and I really had no idea what I was doing. And the first day I struggled big time. But the second day I finally found my stride and now I'm addicted. Watching the solder layer on a joint and component is super satisfying. So I'm going to show you what I learned doing a couple of key solders together. So I'm going to walk you through the first solder, which is a cable that runs from D1 to both of the battery terminals so that the chow can read the battery data and print out voltage and percent charge. Now I'm using GPIO jumper cables, which are composed of several copper strands, but you might be able to get away with a single threaded AWG wire as I mentioned in the original build. I guess I like redundancy. So the first thing here is learning how to cut wires. Might seem easy, but can require some finesse. The key to prepping a wire is to take a pair of wire cutters and apply enough pressure to break through the protective plastic, but not so much that you cut the wire itself. And you'll feel that sweet spot. Once you've done this, then rotate through that exercise around the entire wire, and then you can begin to pull, at which point the tubing should slide right off, revealing the exposed copper. A pair of fine point pliers can be used to twist and unify the copper strands. It also helps to have an apparatus to suspend and stabilize the board as you solder. You're also going to want to use protective eyewear and some sort of fumigator. So the key for me was ensuring that the solder tip was clean by dipping it into some flux and then rubbing off any deposits on the tip. Next, set the solder to around 325 degrees. Once your wire is wrapped through the joint, the key to getting a good solder is to actually heat up the joint and not just the solder. Once the joint is heated, adding the solder will melt and travel around the joint and the metal wire. It should perfectly coat all the components. And there we go. You can see the solder ran through both sides of the through hole, which isn't necessary, but will make for an even better connection. The key is to take your time and let the solder run on the metal connection pads or joints. Once the battery is connected, you may want to do a mid-build multimeter test to ensure that the electricity is flowing through as expected. Also, keep in mind that there are other ways to solder, including using solder paste and hot air, but I haven't gotten that far yet. There are also ways to solder wires using clasps and things like that, but I just got away with soldering the wires directly together. The trickiest part of this solder was the two 10 kilo ohm SMD resistors. These things are microscopic, but again, with a good pair of needle nose pliers and a bit of patience, I was able to get them to connect to the tiny south sides of the battery terminals. I also used a small piece of Kapton tape across the board to ensure we didn't make any errant connections once the wires were pushed up against the board. Now, before putting the electronics into the actual housing, I would test the device by flipping the power switch and ensuring that the OLED turns on, connects to Wi-Fi, and begins displaying data. For charging the battery, remember that the Chow has a battery manager, so it will charge as long as the power is flowing through the USB-C, but keep in mind the power switch must be turned on for the device to charge the battery. Now, one of the trickier parts of this build is getting everything to fit inside, and it definitely felt like a game of Tetris, but ultimately it did come together. From there, I used elastics to compress the parts and added glue where I thought it would support the pieces. Finally, it was time to add the M3 screws, glue the rooftop panels, and add the tires. I then let it sit for a day, and then for the big reveal, I powered her on. And I just can't take my eyes off this thing. So ultimately, this piece of desk ornamentation serves as a clock, but in addition to giving you the current time, it gives you the battery percent charge, the date, the current humidity, and the temperature in Celsius.
And I'm not exaggerating when I say that LLMs were my secret weapon throughout this entire build. They helped me troubleshoot problems, find obscure components, and even write some of the code for this little guy's brain. And that's just the tip of the iceberg. The potential of LLMs in the makerspace is absolutely mind-blowing. We're talking about democratizing engineering, empowering creativity, and making the impossible possible. Not to mention, having Gwyneth Paltrow helping me write C++ code as if I were Tony Stark was just plain cool. To stay ahead of the tech curve, check out this next video. Thanks.